Energy, question 2. A roller coaster ride raises a 400 kilogram carriage to a height of 25 meters, where it stops momentarily before following the track as shown below. Assuming the track is friction-free, calculate for part A the gravitational potential energy of the carriage at point A here. Well, gravitational potential energy is given by mass times gravitational field strength times height, which in this case we have a mass of 400 kilograms, gravitational field strength 9.81 meters per second squared, and the height at this point is 25 meters, meaning a gravitational potential energy of 98,100 joules. For part B, we're asked to calculate the kinetic energy at point B here. Well, the kinetic energy at B will be equal to the potential energy the carriage had at A minus the potential energy it still has at B. This is 98,100 joules, which it had at A, minus the potential energy at B, which is mass times gravitational field strength times height at B, which comes out at 58,860 joules. Alternatively, for part B, we could say that the kinetic energy at B is equal to the change in gravitational potential energy in going from A to B. This is given by the mass times the gravitational field strength times the change in height, and putting the numbers in, the change in height is 15 meters, giving of course the same answer of 58,860 joules. In part C, we're asked to calculate the speed of the carriage at B. Well, we know that the kinetic energy is 58,860 joules, and this is equal to half times mass times speed squared. So we can rearrange this expression for speed as 2 times the kinetic energy over the mass. Putting in the numbers, we get a speed at B of 17.2 meters per second. In part D, we're told that due to a damaged wheel, the carriage just manages to reach point C. If the track from B to C is 35 meters long, calculate the average frictional force produced by the wheel. Well, in this case, the work done against friction by the wheel is equal to the kinetic energy lost, and the work done is equal to the force multiplied by the distance moved in the direction of the force. So, the work done is equal to the force times distance, which is equal to the kinetic energy we've lost. We get from here 58,860 joules. We can rearrange this for the force, and we've got the distance of 35 meters, giving a force of 1,682 newtons, or 1.7 kilonewtons.